Good evening, students. I hope everyone is good, everyone is fine. So, we are back with our next session, that is rapid revision session for the next topic, that is electrochemistry. I hope everyone you know that electrochemistry is one of the most, feared topics as well as one of the most important topics. But after today, this will no more be fearful because we are going to talk about all the important topics and that too all the important type of questions. Okay, so of course it is because it's such a large chapter, so we cannot go to all the concepts. We'll be mostly concentrating on the question solving. Okay, so let's start. What is that? The very first thing that we have to study over here is electrochemical cells. Because we are going to talk about cells here, because I'm not going to talk about all those basics, that what is cell and these things, please. Now, directly come to the electrochemical cells. Electrochemical cells are those devices that is used to interconvert the electrical energy, or you can say interconvert means the electrical energy can be converted into chemical energy, and chemical energy can also be converted into electrical energy. So this is such kind of device. Now there are two types of electrochemical cells. One is galvanic cell, another is electrolytic cell. What galvanic cell does? It converts the chemical energy into electrical energy. So chemical into electrical energy, while electrolytic cell just opposite, that is electrical energy into chemical energy. Okay, so these are the things that you always have to understand. Now galvanic cell. What is galvanic cell? As I have already told you, this is a device where redox reaction is used to convert chemical energy into electrical energy, right? Now, electricity is obtained with the help of oxidation and reduction reaction, that is redox reaction, not a big deal, right? Now, how the electrochemical cell is formed, or you can say in electrochemical cell, how the galvanic cell is formed. There is one very important, very good example, that is Daniell cell. The Daniell cell has two half cells. A cell is made up of two half cells. I hope it makes sense. One is anodic half cell, another is cathodic half cell. Always remember, anode in any cell, either it is electrolytic cell or it is galvanic cell. Anode is the part where oxidation takes place, and cathode is the part where reduction takes place. Very, very, very important point to keep in mind. Here we have this anode, one is cathode. At anode we are using zinc, while for cathode we are using copper. You can see that here we have copper, here we have zinc rod. What is anode or cathode are nothing but they are electrodes. What are the electrodes? Electrodes are, you can say, they are plates, or they may be anything, right? That can conduct electricity, or that can act as either electron, either way. So basically what we are going to do, we are going to dip these electrons inside the electrolytes. What are the electrolytes? I hope you all know that. What is electrolyte? That can conduct electricity through it, right? Here it is also the same thing. Cathode is there, cathode copper, that is put inside the CuSO4. CuSO4, here the electrolyte is there, and here zinc sulfate is the electrolyte. Zinc sulfate has zinc plus 2 and sulfate SO4 2 minus, while here in copper plus 2, and here we have sulfate 2 minus. I will not bore you by telling you all these things, because everyone you know that. Okay. Now here always remember, how do you say or how do you select a cathode or anode? Always remember key. You all have already studied about electrochemical series. In electrochemical series, whichever element is above, or whichever metal is above in that, you can say, electrochemical series, that has the lower SRP value. And if the lower SRP value is there, so what we can say, it has more tendency to get oxidized. So something that gets oxidized, that should be anode. And we know that in electrochemical series, zinc is above copper. Yes or no? Because zinc has the SRP value, though we have not told you, but still you know that all these values, minus 0.76, and it is what, plus 0.34. So you can see that this will have lesser SRP and higher place in the electrochemical series. So it will have the oxidizing tendency, so it will act as anode. While if you talk about copper, it is lower positioned in the electrochemical series. So what we can say, it has higher SRP. If higher SRP, it will have lesser tendency to get oxidized, or we can say that it has more tendency to get reduced. So therefore it will act as cathode. I think it is all making sense. Yes or no? So that's why we have taken copper as the cathode while zinc as the anode. Zinc I have dipped in the zinc sulfate solution, while copper in the copper sulfate solution. Okay, now what we have done, we have connected it through the external wire. Yes or no? We can see that. And here it is, you can see, you can put a bulb here or anything, or emitter or something that can tell you that there is electric flow or not. And once the electric flow starts, why? Because of zinc is converting from zinc to zinc ion, because here oxidation is taking place. So zinc solid is converting to zinc ion by giving it the electron. Where these electrons are there? These electrons are deposited on the plate. Now this electron will try to go somewhere. Of course, where they will go? Here. What will happen? Because there the reduction is taking place. So Cu plus, by taking these two electrons, converting into copper. So they are getting deposited here in the form of copper. Yes or no? And for this whole process, they need extra electron that will be coming through this wire. But the point is, why this electron will go from here to here when there is zinc ion here only? So these two electrons can convert into can be taken by zinc 2 plus 2 only to convert into zinc again. Yes or no? But to stop this or not to happen, what we do? We use a salt bridge. What do we use? Salt bridge. Salt bridge is something that completes the internal circuit of the whole or you can say galvanic cell, and also maintains the neutrality inside these solution. Why? Because as the zinc will keep on going here, the whole solution will become, more and more zinc will go, so it will become more positive. And here what will happen? Because all the copper ion will keep on depositing on the rod. So what will happen? Here sulfate ion will be more. If the sulfate ion will be more, the more and more negative will be there. So as the negative and positive will be there, what will happen? The whole reaction will be stalled or stopped. So for this, to stop this, we use salt bridge. In salt bridge, there are the, let's say, potassium chloride is there. Potassium will go to, you can say, to neutralize this sulfate, while Cl minus will go to neutralize this zinc ion. Okay, so this is something that we have to understand. So basically, that is how the salt bridge works. Now we are going to study about all these points. Now galvanic cell, anode half cell. What is anode half cell? Just see that here in this zinc rod is placed in the zinc sulfate solution, that is anode half cell. Then zinc atom will move in the solution to form zinc ion. Not a big deal. I hope everybody know that it's only the oxidation. Oxidation is nothing but increase in the oxidation number, right? So zinc to zinc ion. At anode, oxidation will take place, release of electron. Everyone we know that. Anode acts as the source of electron and it has negative polarity. Okay, so anode here is having negative polarity only in the galvanic cell, not in the electrolytic cell. Please keep in mind. Next, the electrode potential is represented here by E zinc to zinc ion. Can you see? Zinc to zinc ion, because it is getting oxidized. So this is E zinc to zinc ion. One more thing very important, because it is negative pole and it is the positive pole, so electron will flow from negative to positive. So electron flow direction is this. And as a convention in physics, we know that I, that is current, always flow in the direction of positive charge. So opposite to the direction of negative charge. So current will flow in the opposite direction. I hope it is very important. So electron flow from anode to cathode, while current flow will be from cathode to anode. Very important point to keep in mind. Next, so now we are going to talk about galvanic cell, that is cathode half cell. In the cathode half cell, what we have, we all know that here reduction takes place. Here copper is taken as the copper cathode, that is, and Cu plus 2 converts into Cu by taking electrons. It is the reaction. At cathode, reduction will take place, that is gain of electron. Then positive polarity will be developed. Here what will happen? There will be positive polarity. Their electrode potential can be represented by, because here reduction is there. So what will happen? Copper plus 2 will convert into copper. So E Cu plus 2 aqueous converting into Cu solid. That is how we show reduction potential. Now salt bridge. What is salt bridge here? I hope I have already told you, but still, a salt bridge is a device used in electrochemical cell for connecting its oxidation and reduction half cell sections of selection of electrolytes for salt bridge. Whatever the electrolytes that you are putting in that salt bridge, what are these? Please keep in mind. The electrolytes should be inert. Inert means something that is not going to go inside the solution and start doing their own reaction, or that can interfere in the normal, or you can say original reaction. That should not happen. Next, the electrolytes in the salt bridge should have the same, you can say equal, whatever the cation or anion is there, their ionic mobility should be same. That's why, and then only the positive will make the you can say negative inert, and negative will make the positive inert at the same rate. Next, Electrolytes should not disturb the cell reaction, as we have already seen. Function of the salt bridge. A salt bridge is a U-shaped inward tube that contains a gel permeated with the inert electrolyte. Inert electrolyte, we have already studied. What is that? Next, it connects the solution of two half cells to complete the internal circuit, because externally to it is already connected through the wire. It maintains the electrical neutrality of the solution. Very important. Also, it decreases the liquid-liquid junction potential, though it is not the point and neither we have to here study about. Now, shorthand notation for the galvanic cell. If you talk about the Daniell cell, always remember shorthand notation. Though first of all, I will directly show you the last one that I can go faster. Let's say there is a half cell where copper is acting as the anode, while chlorine here converting into chloride, it is acting as the cathode. What we can say, because chlorine is the in the lower side in the SRP electrochemical series, while copper is above chlorine. I hope everyone we know that chlorine is the bottom side while copper is above it. So copper will act as the anode because that will be getting oxidized, while chlorine will convert it into chloride by getting reduced. Yes. So something that gets reduced is called cathode. And as a rule, IUPAC rule, what we say that it will be kept in the right side, while if you talk about anode, it is always kept in the left side. So what is the anode reaction? Copper solid converting into copper ion. What is this single line? Single line is nothing but it is showing that phase boundary, because solid is converting into aqueous solution. Therefore, there is a phase difference. So therefore, this line is showing the phase boundary. And how much is the molarity? We have to mention that. That is how much? Let's say 1 molar. So Cu plus 2 is how much of the solution molarity is there? We have to mention it. Then there is double line. What is this double line? And because this is going to separate cathode from anode. What separates cathode from anode? Something that is called salt bridge. So this double bond, this double line is nothing but it is called salt bridge. Again, chlorine. Chlorine is in the gaseous state. And how much is the pressure of the chlorine? Wherever the chlorine is there, it is in the platinum rod. Basically, generally it is adsorbed on that. So chlorine gas 1 atm, then single line, that is phase boundary converting into Cl minus 1 molar. That is, these things we have to keep in mind, right? So it is cathode half cell. What about the, if I talk about Daniell cell that we have already studied. Daniell cell ke liye kya ho jayega? What will be the shorthand notation? First of all, make the salt bridge. In the left side, there should be anode. What is anode? Anode is zinc. Zinc converting into zinc ion. Zinc ion is what? It is aqueous. Yes or no? So write aqueous. What is that? How many molar? Let's say it is 1 molar. Now in that side, in another side, what is that? Copper ion. Copper ion, that is aqueous, and it is converting, that is 1 molar converting into copper solid. So it is what? It is the shorthand notation for the, you can say, Daniell cell. Not a big deal. You all can understand it. Next, electrode potential. What is electrode potential? Whatever the electrodes are there, what are the electrodes? One is the anode and another is cathode. Okay. So the potential difference developed between the metal electrode and its ion in the solution is known as the electrode potential. So when we dip the metal into its ion, what happens? There is a electrode potential that comes on the metal surface and the solution junction. So this is called electrode potential. Electrode potential depends on concentration of the solution, nature of the metal, nature of the electrolyte, and pressure, temperature, conditions. Keep in mind. Next, electrode potential are of two types. One is oxidation potential, another is reduction potential. Here, what is oxidation potential? Let's say there is a reaction given in the form of oxidation, A to A N plus. So in such case, what is happening? It is getting oxidized. So how will you write? You will write E A to A N plus. So it is what? It is called oxidation potential. Or you can also say like that, X, that is X N minus converting into X. But in this case, what will happen? They will remove the, or you can say they will give the electron, an electron. Here also X by giving an electron. So what is happening? Electron is being given. So in such case also what will happen? E will be converting into X N minus into X. So converting X N minus into X, it is also a oxidation reaction. So therefore it is what? It is showing oxidation potential. E is showing about the, it is showing about the potential that is being generated. Reduction potential ke liye, I hope you understand. Just write the reaction in opposite way. What we can say? A N plus by taking an electron, and by taking n electrons it converts into A. So what is happening? Here electrons are gained and gain of electron is reduction. In such case what will happen? It will be written as E N plus into A. Similarly, here if you talk X by taking an electron, it's consider Xn minus. So what will happen? It will be written as E X2 Xn minus 1. It is also what? Reduction potential. So if you are writing a reaction in the form of reduction, that will be whatever the potential will be there, it will be written as this in oxidation form. If oxidation reaction, oxidation form. Reduction form, then reduction potential. Not a big deal. Easily understandable. But as a rule, we have to always remember key, as a rule, IU pack considers SRP as standard electrode potential. Electrode potential. Okay. So what we will say, so rather than taking SOP, or you can say OP, oxidation potential, we'll take RP, that is reduction potential. And always remember, reduction potential is equals to minus of oxidation potential, or oxidation potential is equal to negative of reduction potential. Okay, not a big deal. I think it is all done. Like, let's say EX or EA to AN plus. It is what? Oxidation potential. If you try to write it in the reduction potential, AN plus converting into N, what we will have to do? We will have to use this negative with this. Okay, this is something that we have to keep in mind. So always remember, OP equals to negative RP, or RP equals to negative of OP. Not a big deal. How do we find this OP and RP? With the help of something that is standardized, or you can say that we have considered as the reference. Okay, so what we have considered as reference, there are few of the reference, you can say reference electrode which we use. One of them is very important, that is standard hydrogen electrode, that is SHE. What is standard hydrogen electrode? It is a reference, that is primary reference electrode, against which the electrode potential of all the electrodes are measured. So whatever the backside, whatever we have written, reduction potential or oxidation potential, they are standard. In the standard condition, you try to find out for different substances, that is called standard reduction potential or standard oxidation potential, and it is found out with respect to SHE, or it can be found out on the basis of SHE, that is standard hydrogen electrode. How do we make the standard hydrogen electrode? By using a platinum wire or even platinum gauge and passing hydrogen through it on 1 bar of pressure, and whatever the hydrogen solution is there, hydrogen solution means it will be there H plus, and H plus is present in the acid. So there you can take H2SO4 or HCl, that is 1 molar. Not a big deal. So finely divided platinum coated platinum foil, whatever it is, you are passing hydrogen through it, and hydrogen will get adsorbed on that, and it will start acting as a solid electrode. Is that okay or not? So that is why, that is how we make the SHE, and we consider its E, that is either it is oxidation potential or reduction potential, whatever you take, we consider its E equals to 0 or E not equals to 0, that is standard electrode potential. So here electrode potential can either be reduction as well as oxidation, whatever you take, no issues. So it is always taken as 0. So with respect to this, if something shows positive voltage, so we will say positive, in negative, then negative. We will see that. Now, electromotive force of the cell, that is E cell. E cell is sometimes question is, most of the time the question is asked from E cell only. How to find out E cell? If the things are, let's say SRP, that is standard reduction potential of the cathode, and standard reduction potential of the anode is given. What is standard reduction potential? If you have taken the reduction potential at the standard phase. What is standard phase? At 1 bar of pressure, temperature should be 273 Kelvin, or you can say 25 degrees Celsius, 298 Kelvin also you can take, and whatever the what to say, the solution you have taken, that should be 1 molar of concentration, not to miss it. The cell potential is the difference between the electrode potential. Now because once we connect both the electrodes to form the, you can say, cell, in such case there will be a potential difference will generate, and that potential difference, whatever is there, that will be called E cell. Okay, so the cell potential is the difference between the electrode potential, that is reduction potential of the cathode and anode. It is called electromotive force, that is EMF of the cell, when no current is drawn through the cell. and E cell equals to E cathode. Cathode को हम लोग किधर रखते हैं? Right पे. That's why we can write E right minus E left. Basically, what is the correct one? We can write that standard oxidation potential of anode plus standard reduction potential of cathode. But we know that we as a IUPAC has considered SRP as the standard. So what we'll do, we'll convert SOP into SRP. So negative of SRP of anode plus SRP of cathode. What we can convert into? SRP of cathode minus SRP of anode. It is very, I am telling you, very important point always to keep in mind, please. So E naught cell equals to SRP of cathode minus SRP of anode. Okay, now electrochemical series. What is electrochemical series and why do we study about it? I hope you all know that. After finding out all these SRPs, what we did, either we will make a series of increasing or decreasing order of the standard reduction potential. So when we make that series, it is called electrochemical series. And what is this electrochemical series? It tells you about that what has or which of the substance has the more tendency to get reduced, or which substance has the less tendency to get reduced, or more tendency to get oxidized, or less tendency to get oxidized. Simple thing. I will just tell you to please always consider SRP, not to consider SOP. Even if in question SOP is given, convert that into SRP and think by whatever is one rule you have made for you. Okay. What is that? Here all the values that is given is SRP. And in SRP, always remember the top one is lithium and below one we have, okay, here it is Br2, then there will be Cl2 and then there will be F2. The lowest one will be F2, fluorine. And it has the maximum positive while lithium has the maximum negative. It has maximum negative while fluorine has the maximum positive. So what we can say, as we are going from up top to down, SRP is increasing or decreasing? SRP increases. Acha, if SRP increases, what happens? If SRP increases, the tendency to get reduced increases. So what we can say? If SRP increases, then what happens? Standard reduction potential. So means the tendency to get reduced also is more. Then tendency to get reduced increases. If the tendency to get reduced increases, what we can say? What gets reduced? Oxidizing agent or reducing agent? I hope everyone you know that. He oxidizing agent. So therefore, stronger oxidizing character. Okay. So what we can say directly? Can I just say something? Yes. So SRP less than stronger reducing agent. If SRP high, then stronger oxidizing agent. But can anything be oxidizing agent and can anything be reducing agent? No. We are going to talk about how we are going to deal with such kind of question once it comes. Okay. So जो ऊपर है, that is going to be of stronger reducing agent. So they will be stronger reducing agents जो भी टॉप में है, and जो भी जो नीचे हैं, they are stronger oxidizing agent. Any issue? I think there is no issue. Okay. And one more point, always remember कि जो भी ऊपर हैं, they will always get oxidized. जो भी नीचे हैं, they will always get reduced. In a reaction, जो भी ऊपर हैं, whoever is placed upward, that will be getting oxidized, preferably oxidized, while those who are at the lower side, they will preferably get reduced. So higher placed substance gets oxidized in a reaction. So therefore acts as anode, while lower placed substance gets reduced in a reaction. So therefore acts as cathode. Any doubt? No doubt? I hope so. It is a very easy and very understandable thing. Now, free energy change for the cell reaction. So here we have this free energy change for the cell reaction. What is free energy change? I hope you know that it is the maximum useful work done. Yes or no? What is work done? In any, you can say electrical work done, it will be equal to charge into potential, that is N into F into E, that is delta G equals to NFE. You have to keep in mind delta G equals to minus of NFE, very important. What is this N? N is the number of electron that is exchanged. N is the number of electron that is exchanged. F is the Faraday charge, that is 1 mole of electronic charge. E is the E cell, that is EMF of the cell. N is the number of electron exchanged in the reaction. F is Faraday charge. Faraday charge is how much? 96,500 coulomb. While E is, I think everyone you know that, EMF of cell. What about this? If you have taken in the standard condition, then delta G naught will be minus of NF E naught cell. I hope it is all very clear. Nernst equation, how do we get that? Nernst equation can be converted from, and how do we get that? Because delta G equals delta G naught plus RT ln Q, we have already studied in thermodynamics and chemical equilibrium here also. What we can do, we can put all these delta G equals to NFE and delta G naught equals to minus of NFE. What we get finally? We get E cell equals to E naught cell minus of, we can say, RT by NF ln into Q, ln Q, that is natural log of Q. Here what we can say, we can convert it into E naught cell minus 2.303 RT by NF log base 10 Q. In such case, what we'll get, on putting the standard condition, on putting standard condition, that is generally T is what? 298 Kelvin and F key value 96,500. If you put all these things, what you get? E cell comes out to be E naught cell minus of 0.0591 divided by N log of Q. That is the final Nernst equation. Very important. I hope you know how to write Q. If there is any reaction that is in equilibrium, you know how to find out Q. Yes or no? Chalo आगे बढ़ते हैं. Now directly we will come to the question solving. Question part mein I'm not telling you about the concentration terms. I will directly take the question and on that basis I will solve the question. That's it we are going to do. Chalo. Now the E naught of M plus 3 to M plus 2 values for Cr, Mn, Fe, these things are given. Okay. For which one of these metal the change in oxidation state from plus 2 to plus 3 is easiest? Means plus 2 to plus 3 means oxidation or reduction. I hope everyone you see that it is oxidation. If oxidation is easier, what we can say? Acting as the reducing agent. So means it is talking about strong reducing agent. For strong reducing agent, what should be there? SRP should be low. Where the SRP is lowest, where SRP is here minus of 0.41 and all SRP is highest. So what we can say, which can be easily get oxidized? Of course we can see that here chromium, the first one is chromium only. Yeah, so chromium is the correct answer. I hope it's very clear. Next, for the cell reaction 2Fe plus 3 plus 2I minus converting Fe plus 2 and I2, E naught cell ki value is this much at this much temperature, then delta Rg, okay, so Gibbs free energy it is asking for. Okay, standard Gibbs free energy equals to minus of NF E naught cell. Any doubt? No doubt. What is the number of electron exchange? Always remember how many of the number of electron being exchanged? Fe plus 3 to Fe plus 2. So how much? 1. How many moles are there? We have taken 2. 1 2 the 2. Okay, here what about this I minus converting into minus 1 to 0? How many electrons are there? How many of the, after balancing? 2. So 2 into 1 is how much? Always remember 2. Okay, so always remember how to find out N value. N equals to LCM of electron exchange in the reaction. So 2 and 2 का LCM is how much? 2. So N की value कितनी हो गई? Minus of 2. F की value 96,500 into E naught cell की value कितनी हो गई? Here it is given 0.24. You can put that and get some of the values. I hope it will be option A. Please you can check that. Okay, you will get it in joules. First of all, you will get it in joules, and joules ko kilojoules mein you know how to convert it. Divide by 1000, you will get one of these. Okay, Now E value for the cell reaction is for the reaction Cu to Cu plus 2 and this to this is okay. Can you see that? What is the concentration cell? Concentration cells are those kind of cells where the electrode as well as the electrolytes in the cathode as well as anode is taken same. Array, then how will the battery will form? Battery or cell will be formed only by changing the concentration of the electrode inside both the cells. Okay, so always remember in such cases, due to the change in concentration or difference in the concentration, the current is flowing there. So what we can say in such cases, it is, that's why called concentration cell. चलो आओ जरा ध्यान से देखते हैं. Can we see कि here there is going to be oxidation? So it is what left side, it is always anode. So what is anode reaction? Anode reaction is Cu to Cu plus 2. And how much is this? It is 10 to the power minus 3 molar. What is the cathode reaction? I hope you can see that cathode reaction comes out to be copper plus 2. That is given how much? 0.1. That is 10 to the power minus 1 molar converting into copper solid. Okay, so what do you do? Just add both of them. Add both of them, you will see copper copper cancel. What we can say, and of course there is going to be 2 electron in the right side, while here it is going to be in this side 2 electron cancel. So Cu plus 2 of 10 to the power minus 1 converting into Cu plus 2 of 10 to the power minus 3 molar. Yes or no? So what we have got? We have got the net cell reaction. Net cell reaction. If you have got the net cell reaction, can you not find out with the help of Nernst equation? Yes, we can do it. What is Nernst cell equation? E cell equals to E naught cell. E naught cell की value always remember. For concentration cell, E naught cell equals to 0 because E naught of cathode minus E naught of anode. And because cathode and anode both is made up of same material, so consider it as X. So it will also be X. So X minus X will come out to be 0. That's why always E naught cell value for concentration cell is going to be 0. As a rule, please remember it. So E naught cell will be 0 minus of RT by NF ln, that is of Q. What is Q value here? Whatever is the concentration of the product, that is 10 to the power minus 3 divided by concentration of reactant, that is how much? 10 to the power minus 1. What is the N key value? N key value in the whole reaction is how much? 2 electron were being exchanged. So N key value कितनी हो गई? N key value is 2. How much is this? Can you just see that? It can be 10 to the power minus 2. Can you see? Okay. Can we just get some value from here? Okay. So whatever is the number, can we just raise the power? You know that X log A can be written as log A to the power X. I'm doing the same thing. I'm taking 1 by 2 here as the power. What we can say? Minus of RT by F ln 10 to the power minus 2 raised to the power half. 2 cancel. What we can say? 10 to the power minus 1 is how much? 0.1. So minus of RT by F ln 0.1. So which one is the correct option? I think we all can see that option B is the correct option. Okay. See, the time ki kami hai, that's why we are being so fast, but not a big deal. You also have to do the solve the question, these kind of question as quick only as I'm doing it here. Okay, in the examination hall. For the reduction of the silver ion, which copper metal, silver ions, with copper metals. Okay, the standard cell potential was found to be this much. Okay, that's a very good thing, that standard E naught cell value is given at 25 degrees Celsius. The value of standard Gibbs energy is delta G naught will be. Okay, I hope you all can find out. Delta G naught equals to minus of NFE. E naught ki value given. F ki value, you know that. You just have to find out N. How do you find out N? Just write the reaction. We all know that in the electrochemical series, which is higher, copper or Ag? Let me tell you, copper is placed higher than the Ag. So what is there? Copper will be oxidized while Ag will be reduced. So how the Ag will be reduced? Ag plus, and Ag plus will convert into Ag, while copper will convert into Cu plus 2. Always remember, N is nothing but N, take LCM of 1 and 2. Why 1? Because Ag is changing from 1 to 0. The change is how much? 1. While copper ke liye it is going from 0 to plus 2. The change is how much? 2. So 1 and 2 ka LCM is how much? 2. So n ki value kitni aa gayi? It is 2. So what we can say? Delta G naught equals to minus of 2 into F into E naught. F ki value rakho, E naught ki value rakho, you will get some of the values. Not a big deal, easy, right? Next, for a cell involving one electron and one electron, okay, if one electron is involved, so it is telling that n value is how much? 1. Yes or no? Easy. E naught cell ki value given this much, okay. The equilibrium constant for the cell reaction, okay, that's a good question. You can see, we all know that delta G equals to minus of n, that is how much? F 1 into F into E naught. E naught ki value kitni di hui hai? 0.59. So it is how much? Minus of 0.59 F. This is the G naught ki value, and everyone you know that G naught equals to minus of RT ln of K. Yes or no? Now what it is asking for? It is asking for K. Okay, K. So what we can say? It is minus of 2.303 RT log of K. Let's just equate both of them, because it is also delta G naught, it is also delta G naught. Why? Because one relation of delta G naught is with E naught, while another relation is with K, and we are equating both of these. What will happen? Minus of 0.59 F will be equal to minus of 2.303 RT. Okay, 2.303 RT by F is given. Okay, so just take this F this side. Take this F this side log of K. And what is this value given? This value is given to be 0.059. So minus of 0.059 log of K comes out to be how much? Minus of 0.59. Minus minus cancel. 0.59 this cancel. How many times? 10 times. We all know that here base is how much? 10. So we know that what is the rule of log? Basic mathematics, I think everyone you should know. Log of, you know, a to the power b. If it is given x, then what we can say? B equals to a to the power x. This base there, and whatever is this value, it comes to the power. So here what we can say? K equals to 10 to the power 10. 10 to the power 10. Basic mathematics is very important. I think you all can see that such kind of question you can solve it very easily. Next, if the E naught for a given reaction has negative value, which of the following gives the correct relationship for the values delta G naught and K equilibrium? Okay, what is given? E naught for the given reaction has negative. Okay, if E naught is negative, we all know that delta G naught equals to minus of N F E naught. If it is negative, then negative will be positive. Then delta G naught should be positive. Okay, delta G naught positive, where it is? Either A or C or D also. Okay, so what about K? Let's find out. Delta G naught equals to minus of RT ln K. What we can say? Because it is positive, negative, positive, negative. What we can say? This will be some negative value. We can say minus of delta G naught by RT ln equals to ln K. We all know that this is a negative part. It is what? Negative. And log becomes negative only when this K log x, here x is, let's say, or I'm telling you, log K, if K is more than 1, will be positive, or we can say log K equals to is a positive value if K is more than 1. Log K ki value is 0 if K equals to 0, and log K is less than 0 if K is less than 1. Not a big deal. I hope you understand it. So here what is there? Because it is a negative value, so what we can say? K is less than 1. So which of the option is correct? K equilibrium is less than 1 while delta G naught is more than 0. Any doubt? No doubt. So as a rule, always remember spontaneity criteria. Spontaneity criteria for a cell comes out to be, everyone you know that delta G should be negative or should be less than 0, and because you know that delta G equals to NFE, so E cell should be positive, or you can say more than 0 as a rule. I'm not writing about delta G naught or E naught, I'm writing delta G and E, please keep in mind. Next, standard electrode potential for Sn plus 4 to stanic to stannous is given something. Okay, there is, can you see it is reduction? So it is SRP or SOP, it is SRP value. SRP value is positive. While for Cr plus 3 to this, it is also SRP value. It is given positive or negative? Negative. Okay. These two couples in their standard are connected to make cell. Then cell potential will be. Can you see which is negative value? I think you can see that here SRP is negative. If negative, so means it will act as anode. Because it is positive value, so it will act as cathode. Because we know that if SRP value is positive, it will get reduced, and where a reduction takes place at the cathode. So therefore it will act as the cathode couple. It will be a cathode couple while it will be a anode couple. I hope you understand it. So what is E cell value? E cell equals to, E naught cell equals to E naught of cathode minus E naught of anode. What is the cathode? Cathode ke liye what is SRP value? 0.15 minus of what is the anode ke liye value? 0.minus of 0.74. It is how much? Minus minus plus. So 0.89 volt. 0.89 volt. That is positive or negative? Positive. Of course it is positive. So plus 0.89. Next, for a cell involving one electron, E naught cell equals to this much. Then equilibrium constant for the reaction. I hope this is the question we have already solved. Not a big deal. We got this option C. The pressure of hydrogen required to make the potential of hydrogen electrode 0 in pure water. Acha, in pure water, what is at what temperature? 298 Kelvin. Matlab 25 degrees Celsius. You know that for pure water, if it is telling that, and hydrogen, it is talking about hydrogen. Of course, there should be some reduction reaction. You can say redox reaction. Okay, let's talk about what kind of redox reaction will be going there. 2H ion taking 2 electrons, converting into H2 gas. And how much is this? It is, I hope you understand, H ion is what? In water, H ion concentration is how much? At 25 degrees Celsius, H ion concentration equals to 10 to the power minus 7 molar. I hope it is all. You all know that. Character of water. At 25 degrees Celsius, H ion and OH ion, both of them are what? 10 to the power minus 7. That's why we know that Kw is how much? 10 to the power minus 14. That's why pKw comes out to be 14. Yes, remember. So this is the reaction. What is the N value? N value, you can see that 2. So N value is how much? 2. This is the reaction. And what is telling that? That making the cell potential to be 0. So means E value is how much? 0. And E is equals to what? E naught minus of 0.059 divided by how much? We all know that N by N log of, what is this reaction? H ion aqueous, or H ion whatever is this, H ion concentration later on. If it is gas, so you will use pressure of hydrogen divided by H ion of square. Why? Because 2 moles we have taken. Yes or no? It is asking for what is the pressure of hydrogen. So basically pressure of hydrogen. Whenever something is given in gaseous phase, use pressure or partial pressure of that. Okay, an issue. Now we know that E naught for hydrogen electrode is how much? 0 as a rule. We know that. And E is also 0. So what we can say? It will be equal to 0. If this whole part becomes equals to 0, so send this part also this side. So pressure of hydrogen by H ion concentration to the power 2. We know that H ion concentration is given how much? 10 to the power minus 7. 10 to the power minus 7 power 2. 10 to the power minus 14. 10 to the power minus 14. And it is equal to how much? 0. What log of what equals to 0? Log of, because we know that log of 1 equals to 0. So therefore pressure of hydrogen by 10 to the power minus 14 equals to 1. So pressure of hydrogen comes out to be 1 into 10 to the power minus 14, that is 10 to the power minus 14 atm. Can you see option A is the correct option? Any issue, any doubt? I think you all can see that. These are very good questions. I am taking all the good questions out of electrochemistry PYQs. So please, electrochemistry PYQs, please take care about that. Standard electrode potential of 3 metals X, Y, Z are given these. Okay, the reducing power. Everyone we know that lesser the SRP, stronger the reducing agent. Where the least value minus 3, then minus 1.2, then 0.4. So सबसे strong reducing agent कौन हो गया? Z, and then X, and then Y. Z is more than X is more than Y. Option C. Then given is the question, copper plus 2 taking 2 electrons convert into copper, while Cu plus 2 by taking 1 electron converts into Cu plus E naught values are given. Okay, now electrode potential E naught for the reaction Cu plus converting into Cu. Always remember, because E cell is an you can say it is intrinsic property or intensive property for a reaction. If you are adding or subtracting, E cell is not added or subtracted. But what is extensive property? I hope everyone you know that Gibbs free energy is an extensive property. So if you are adding to reaction or subtracting to reaction or multiplying with anything into any reaction, what we can say, we can make the same kind of changes in the delta G value also. Yes or no? Rather than taking E cell, we just take delta G naught, delta G or delta G naught. Okay, so we are going to do the same thing here also. So how to get this reaction? I think if let's say that this is reaction 1, let's say that this is reaction 2, let's say that this is reaction 3. So how with the help of reaction 1 and 2 we can get reaction 3? Let me tell you. Reaction 3, you can just see that cuprous is in the left side, while cuprous here is in the right side. So means reaction 2 is being reversed. So minus of R2. What about copper? Copper was there in the right side. Still it is in the right side. So means the reaction 1 is taken as it is. So what we can say, delta G naught 3. So for let's say this is the delta G naught 1 or delta G naught 1. Consider for this delta G naught 2 and consider for this delta G naught 3. So what we can say, delta G naught 3 equals to delta G naught 1 minus delta G naught 2. Yes or no? Now we know that delta G naught की value कितनी होती है? Minus of NFE. Minus 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 cancel. F cancel. What will happen? Only remaining part will be N and E. So N3 E3 equals to N1 E1 minus of N2 E2. What is N value here? I hope you can see that what is the number of electron being exchanged? It is N1. What is the number of electron being exchanged? N2. What is the number of electron being exchanged? N3. So N1 equals to 2, N2 equals to 1. So it is what? N3 equals to 1. 1 into E3 equals to, or you can say make that equals to N1 की value 1, नहीं sorry 2 into E1 की value is how much? 0.337 minus of N2 की value is how much? 1 into what is E2 की value? 0.153. Please solve it and get some of the answer. You will get few of the answer. Okay, not a big deal, just solving part. Which reaction is not feasible? Always remember, if for feasibility what we have to see कि जो भी ऊपर है, whatever is the higher side, that should get oxidized. जो भी नीचे है, that should get reduced. Okay, so Ki Br2 converting into Kbr and I2. I in the electrochemical series, we know that सबसे ऊपर कौन? I2, फिर कौन? Br2, then Cl2, and later on at last it will be F2. So I2 should be oxidized while all others should be reduced with respect to, I hope you understand, Br2 should be oxidized with respect to chlorine and fluorine, while chlorine should be oxidized with respect to fluorine. So can we see that iodine being higher side, it is getting oxidized, and Br2 being lower side, 0 to -1 getting reduced. बिल्कुल सही है. तो ऑप्शन है not feasible, because it is, because ये तो सही हो रहा है ना, so it is feasible, it is feasible. Okay, because higher side is getting oxidized, higher side is getting oxidized, so बिल्कुल सही है. Br is above I2, Br is below I2, Br is -1 going to Br2. Can you see -1 going to 0? No, because it is Br2 is, bromine is lower than iodine, so it should get reduced, but here it is getting oxidized. So option B is the correct option. Not a big deal. I hope you can understand it. Such kind of question बहुत easily. Now standard reduction potential of the following reactions are given. Okay, these are the values. Okay, can you see SRP values are given? The strongest oxidizing and reducing agent. Always remember, for strongest reducing agent, what should be there? SRP should be minimum, and strongest oxidizing agent, the SRP should be maximum. Okay, let's see that where the SRP is minimum, here SRP